starting today with an introduction to hardware from Severin, who is our head of hardware. So with that, I'll go ahead and pass the mic over to Severin, and Severin, take it away.
Thank you very much. Before I jump in, you can see my mouse, I assume. Just I'll probably point at things later.
Yes, that's right.
Excellent. Hello, all. I'm Severin Smith, currently Director of Hardware Engineering. So, I'm jumping in today to give a presentation about the hardware we make here at HeadSpin. So we produce physical products that we deploy around the world, and talk a little bit also about the deployment process and the people involved in that, the teams involved in that. So I'll touch more on the teams at the end when you have the context of the hardware, but I myself, I'm responsible for the design of the physical products and the process around that. And we have teams that do, the logistics around the world, that deal with running all of our network and infrastructure, these kinds of things. But I'll touch more on that at the end. Let's jump into it. So there's an agenda up here at the front of the meeting. I'll just skip over that. It's a reference for you guys later if you're looking through this presentation. So the first question I think I want to ask or answer briefly is sort of, why do we make hardware? I think when we talk to new clients or new people join us, people are often even surprised that we make hardware. So let's sort of revisit the basic premise of HeadSpin, which is we allow people, and a lot of things here are framed from my perspective as the hardware person. Obviously there are lots of framings on what we do and what our core goals are, but we let people test on real devices. So we're talking about actual bare metal phones that are also can be very high performance relative to emulation. And we support, when we talk about real phones, we get other benefits like phones that are specific to different regions of the world, features that can't be emulated directly, like, if you want Google or Siri or Bixby or special apps, that only come with certain phones. We're also testing on the edge, right? We're testing throughout the world where you're locating that phone in that location. You have internet or even a mobile plan or a voice plan from that part of the world. You have regional apps and features, different TV shows are available in different regions, that kind of thing. Oops, sorry, got ahead of myself here. So just to drive that point home, what I'm showing here is a side-by-side of, on the right, you see the HeadSpin UI, where I'm interacting with a phone. On the left, you see the actual physical phone sitting, in this case, in a rack here in Toronto, running that interaction. So again, I think when people are new, this might be lost on them, that there is a physical underlying phone that we are interacting with. So what we make then, one of the primary reason we make hardware is we have to make some hardware to support a phone like this, to have it exist in the wild, to be able to cool it, to be able to charge it, etc. We'll go over that. So this is why we make physical products. I'm going to jump in a minute and describe the physical products we make in a certain amount of detail. But I want to just step back first to also contextualize some of the things I'll talk about, and talk about the HeadSpin architecture, sort of from my perspective, again, slightly simplified so that I can refer to it throughout this presentation. So as we just discussed, we have phones. I also throw in here, we have other kinds of devices. So devices and AV boxes, for example. So there's these phones located, for example, in our office in Toronto, like the one you just saw. First of all, in that location, we need a computer to drive debugging on that phone. So we tend to have, a Linux computer for Android phones, a Mac computer to support iOS phones, but there's physically a phone located here in Toronto to support the debugging of a given phone, like the phone you just saw in that video. And of course, we have, 80 plus, I don't actually know offhand, locations around the world where this is reproduced. So we have many computers in Palo Alto, in South Africa, in Toronto, all connected to individual phones that are available to our customers. All that stuff, that doesn't include the web interface and the machine learning and all the data analysis we do. That all lives in cloud servers. We use AWS. I'll just refer to that as a unified controller as a shorthand. I mean, there's lots of complexity to that. And I'm definitely cutting corners in the description, but I'm saying that all these computers we have around the world reach back to our central servers somewhere. And it's those central servers typically that our customers connect to with their computer. There's some asterisks here, I won't get into it, but generally speaking, the customer connects to AWS and through that reaches the phones. That means in their browser, they use our interface, and they can also use our command line tools, which is also where our reverse bridge product comes in, where a customer can take their local phone and bridge it back into our system. So hopefully this make sense to you guys as a general architecture. And just we can refer to it a bit as we talk about the components and some of the different deployment models. Wants to link to them. So it's a plastic enclosure, plastic so that it doesn't block radio frequencies. So we still have Wi-Fi and mobile access. It locks with a pin code. So it's an enclosure that fits in a standard 19-inch wide 4-post rack. You can see it here racked in our office in Toronto. And what happens when you enter your PIN code on the screen there is you can pull this drawer out, and inside it, this is what you'll see. And so the first thing you'll see, of course, are slots for phones. So this box hosts up to 24 phones. So, like we discussed before, there are things we need in order to be able to support phones all around the world, right? We need to charge them. We need to be able to debug them with computers. We need to keep them cool, which is very important. We also need to support peripheral features like connecting with audio to these devices, which we'll all cover a little bit here. So this drawer slides out and you have up to 24 phones. The drawer, as I said, locks. You have a PIN code to unlock it. If we jump back to this diagram here, so here are the phones. That's what we're talking about that are on the edge. Then if you look back here, there's these little silver squares that are actually computers underneath. So those are the Linux or the Mac computers. In this case, it's 3 Linux computers you're seeing in this picture. So again, that's these computers distributed around the world in different data centers or locations. Over here on the right, these white squares. So in this picture, you're actually seeing our new generation Bluetooth audio under test, but underneath of these lit up circuit boards you see would be the USB hubs for our phones. So each computer has a USB hub, connects all the phones to you. Of course, cooling in the box. So cooling is very important to us. I think, it's easy to underestimate that phones aren't really designed to run 24 hours a day in a potentially hot environment, say in a data center or in parts of the world where the temperature is on average quite high. So blowing a lot of air across the phones is really important to extend their lifespan. We see phones fail primarily because their batteries will bloat, from overheating over time, more cooling in the rear. And in this picture, you see our Bluetooth audio hardware, which I will explain in a little more detail in a minute. This is the 2nd generation one that we're just starting production of currently. But this provides audio connectivity to the phone so that people can, play music and talk and make calls on phones. This view here, so on the left, we're seeing this same tray we just saw. We were just looking at with the phones in it, with no phones in it. So this is an empty tray. You can see the edge of the P box here. I just want to show you can lift up this tray and see what's inside. So first of all, these here are those USB hubs I was talking about without the Bluetooth audio. But over here, we have the inside of a tray. I won't spend a lot of time on this, but I thought it was just interesting to show. There's a network switch to split all the computers. There's a power supply. Here we see 2 Linux hosts and a Mac host. So that's a quick tour of the P box. We'll mention briefly also the tray version of the P box. So you'll see below this picture I showed earlier, there's this version here, which is just the 2 white trays that we would have seen inside the P box. So I'll just back up for a second to an overall view. Sorry. You can see these white trays here that are in the tray that pull out in the P box. We sometimes deploy those on their own, just on a shelf. So that's typically about 8 U high. It requires a shelf. It doesn't just rack on a shelf on its own. Okay, jumping over now to some other things we make that are perhaps a little more complicated to explain. We have the AV box. So the AV box itself are these large black squares you see racked in the racks here. So of course we have 10 here, 5 in each rack. These are 8 U tall enclosures that are designed for audio-visual testing, for testing media devices. We'll try and go over some use cases, but there's a number of configurations that can go into these boxes. But at their simplest, they are boxes that are light-proof and sound resistant. They have a certain amount of sound dampening, which you can use to test different media setups. So here's a view inside one of those boxes. You can see, there's a little bit of cooling at the back. There's this quite a heavy duty soundproofing so that if you're testing, a smart assistant or something that's making noise, it's isolated to a reasonable degree from adjacent boxes. There's some pass-through ports down here. Again, we don't want to let light or sound in, so we don't want to have a hole for cables. It also has these brackets inside, which you'll see in a minute there are different uses, but they're mounting points to put a phone, a screen, other things, and they're adjustable so that we can adapt different configurations. You can see here a phone on one of these brackets being moved around to give you a sense of what I mean by adjustable. This product is relatively new. It came out in the last year, really, is when we started using it a lot. Yeah, and it's something I think it's still definitely open to feedback and under development. I didn't have a lot of pictures of actual setups inside AV boxes, but I'll just show one here. You can see a phone looking at an HDMI screen. We'll show some diagrams of this in a minute. I just thought it was interesting to show one actual setup here. So let's talk about a couple AV box use cases quickly. There's really been a lot of different use cases made of it, but I'm just going to touch on the three that have seemed most common so far. So probably the most common one is this sort of media testing of OTT devices, so of things like Chromecasts and Rokus. So what you end up having is one screen, which will be attached to, and this is a standard screen we provide that fits into the box, that will attach to a Chromecast, Fire Stick, Apple TV, Roku, some other similar devices, and we'll place a phone in front of it that can act as a camera to capture the screen. And the point of this is mostly to be able to test things like DRM content, like when it's fair use, of course, so that, if you test Netflix or you're testing, maybe a Discovery Plus app, something like that, where we can no longer capture the screen due to encryption for DRM content, we can do it via the camera. It also lets us test some other features of those kinds of devices. Maybe the device is not fully supported by our platform, but can still be supported this way. Maybe there are built-in features of the device, like sometimes there is a smart assistant built into your Chromecast, for example, that you might want to be able to test by playing audio. I noted on this slide, we natively support at the moment Chromecasts, Fire Sticks, and Apple TVs in terms of being able to automate them. We are working on Roku support. Other devices beyond that would have to be supported by what we call manual automation, which means that there's an app that runs on another phone that can act as a controller for the device. So the example for this would be a Roku, which we'll see an example of in a minute. Roku has an iOS and an Android app that acts as a TV remote for your Roku. So we can simply go control that TV remote in our platform, and that takes the place of us being able to automate it. We tend to refer to that as manual automation in this context. I'll also just make a note, of course, a lot of details here that these OTT devices, specifically Chromecast, Fire Stick, and Apple TV that we support, we do also support outside of the AV box. So you could put just a Fire Stick, for example, in a P box, but there'll be no DRM content support. So you can just do functional testing. You can't open any streaming apps, for example. So just this is a layout here. You can see, maybe this helps you understand, the screen, a camera facing it. Sometimes we place that third device I just talked about to act as a remote. I think the next slide will show us this happening in real life. So here we have on the left, me taking a video inside an AV box in our office of the HDMI screen. And on the right, you can see me interacting with a Roku. So I have the Roku app open on the left because we don't yet natively support Rokus. And on the right, you can see a camera capturing the screen, the HDMI screen. So you can see I'm actually interacting with that device that's acting as the Roku remote. And when I'm in the Roku remote app, and I click the buttons, I see it both in the platform on the right, and you can see it's actually physically happening on this TV. And again, this TV could be anywhere in the world. How do I get out of the slide here? There we go. Briefly, a couple other use cases for the AV box that we've seen. We've seen smart speaker testing where we'll put, Google Mini or some sort of Alexa device, and we'll put it with one phone. And that phone can play and record audio. So you can say, hey, Alexa, whatever the case may be, and inject commands. You can, of course, also use the camera on the phone if you want to monitor, a small screen or lights that are on that device. This, of course, is where that soundproofing comes in, right? If you have 2 or 3 Alexas in different boxes next to each other, they have to not hear each other or else you'll have problems. The last setup I'll talk about is, of course, we could just put 2 phones next to each other. The obvious use cases here might be something like voice calling or voice and video calling in certain situations that we can't support elsewhere, but most commonly testing fair use DRM situations. So the Netflix apps, the Discovery Plus apps, where they want to make sure that it's working as they expect, but they're not able to do screen capture. We've seen a lot of other long tail of use cases here, but I won't go into too much detail beyond that. Something new that is that is adjacent to the AV boxes are what we're calling TV racks or TV boxes. Name Open to suggestions for the naming of it. Definitely have a better name. This is a new product that it's still under development. So we're previewing it to some customers. We have a few TVs just being set up this month for some customers. So it's basically a rack. It's similar to a server rack, but we've designed it ourselves that supports up to 65-inch TVs. That number may change over as we sort of finalize the design we want here. And depending on the size of TV, we can put 3 to 5 TVs in a rack like this. It's very much the same architecture as the AV box. We have, some device acting as a camera, capturing a TV across from it. I'll just make a few notes about this. So obviously this is a kind of a new design, so subject to some changes still. We're planning to cover it with something that will block light. So there will be a fabric covering to this that will be opaque to light. This will probably be, ready within the next couple of weeks. We're prototyping it right now. Because we're doing a fabric covering, which drives down, in order to make this product easy to ship around the world and easy, not really bulky, audio has to be captured over HDMI. We're not capturing the actual sound playing out of the TVs. We don't want to be producing, loud sound from the TVs because we can't isolate that. In terms of TV support, there is work currently to support Tizen TVs, and that's coming sooner. And LG WebOS, I know we are looking into as well. Other TVs we don't plan to natively support at the moment. Although again, if those TVs have an app that runs on iOS or Android that you can use to control the TV, that will let us do, what we call manual automation. And of course, there are also third-party companies that sometimes provide ways to automate TVs that we are potentially able to integrate as well with those servers to connect to them. So we have this product, which is a 2U, I believe, server blade that can contain up to 4 computers, networking equipment, and a power supply that was really designed to go with the AV box and now the TV box. So back to our diagram, it's these computers, right? The AV boxes and TV boxes just represent devices on our far left. We still need this layer of computers. And so that's what this product serves. I won't go too far into the details of all the components we make, but I'll spend a little bit of time talking about our Bluetooth audio solution because it's something we're trying to make standard across our platform, and it is probably worth understanding a little better. So before I explain our actual solution, I want to think on just how Bluetooth headphones themselves work, so you can compare to that. So in a Bluetooth headphone, you have a phone, and it speaks over a Bluetooth link. It sends your music, your calls, your YouTube to your headphones, and your headphones, when their microphone is active, send back, speech that you make to the phone also over Bluetooth. And those Bluetooth headphones, unsurprisingly, are connected to your ears and your mouth, and that's how the sound gets to you. What we've done is we've gotten in the middle of this process. So instead of there being Bluetooth headphones, we have this special Bluetooth audio board that we call HSBT, just short for HeadSpin Bluetooth. So HSBT Bluetooth audio. So that music, those YouTube videos, those calls from your phone get sent over Bluetooth to the Bluetooth board. And then instead of going straight to your ears, they're sent into a computer over a network all the way to the customer's browser and then out of the speakers on the customer's computer. And that's how the customer hears it. So we're basically proxying the Bluetooth headphones all the way through to the customer's browser. And same thing, if the customer speaks to a microphone attached to the computer, it goes through the browser, through the network, into our Bluetooth card, and then is sent across Bluetooth to the phone. So the phone basically perceives that it's just connected to Bluetooth headphones. But from our perspective, we can bridge that audio through. So you can be listening as if you were on Bluetooth headphones, but actually the phone can be on the other side of the world, thanks to this piece of hardware. Our Generation 1 board looks like this. You may see it inside some of our existing hardware if you're in the office or in other locations. This was one board for every 8 phones, or one board per computer was the model at that time. You can see it would get installed between the servers in the tray, if you remember back to the beginning of the presentation. I mentioned earlier the new generation, which looks like this. Here we're changing the architecture a little bit. We have one of these boards per phone. Just briefly, this new generation has some new features. We are have a more low-level connection with the Bluetooth link here. So we're able to, understand more about what's happening, emulate some button presses like volume up, volume down, play, pause, this kind of thing. And we're still testing this board. We're hoping that we'll be able to also increase eventually the density at which we can deploy these, although we haven't proven that yet. Currently, there's a limit to how many of these Bluetooth boards we can all place in one location before we start to have just too many devices all packed together. Lightning fast, I'll just mention some other things, give you a bit of flavor that we make. We make a wind tunnel for the P-Box tray. So again, cooling phones, very important. We make a power unit that I mentioned earlier. I'll pause for a moment. We make a product we call Bluefinger, which is a little USB dongle. You can see a sort of stock photo of it here on the right. This dongle acts as a human input device, which is a fancy way of saying a mouse and keyboard for a phone. The reason we make this right now is to enter PIN codes. So if your iOS phone locks, it's not possible to keep debugging it until it's unlocked. And so this little dongle acting as a simulated keyboard can type in your PIN code and unlock it. This is very important for us at the moment, and this is the primary use case currently for companies that use mobile device management and MDM with their phones, where they force their phones to lock or to have various security settings that cause it to lock more frequently. We can continue to work with our phones because we're able to unlock them remotely using this. So keep this product in mind if you interact with customers who run MDMs. We make a bunch of other bits and pieces of hardware, but I just wanted to give you some flavor there. I'm going to pivot now a little bit, having covered a bit of a flavor of the hardware we make, and talk a little bit about deployments. So again, going back to the whole why do we make hardware and what is the hardware part of our company, we deploy devices all around the world, both to customers for customers to use on their own premises, as well as into data centers and with contractors around the world. So what are the different models of that? And what are some of the challenges that, from my perspective in hardware and along with the operations and deployments teams that we face? So the most obvious and common model here is the cloud model. So when we talk about cloud, we're talking about hardware and devices that HeadSpin hosts and maintains all around the world. So we host devices, in our offices, in data centers, with contractors in other locations. So this means that customers come to us and they just jump on the website and use our cloud devices, and they don't have to interact with any of that hardware at any time. There's two flavors of cloud deployments. There's dedicated cloud deployments, which are when the device is exclusive to a customer, so they have constant access to it. If they set something up on the device, that setting persists over time, and everyone on the team for that customer has access to that device. The other model is the shared model, where customers will timeshare devices that will be all around the world. And of course, then they don't necessarily, they're not able to persist, their tests and things over time. Just to have you guys think about it from a deployment and hardware perspective, keep in mind that, again, these are real devices we purchase around the world. So if you request a device, in Japan somewhere, someone has to order that device, receive it, physically set it up, right? That's something to keep in mind. And these devices require physical support 24/7. Our logistics team, which Michael Ramirez runs, they'll be the ones who will reach out to a data center or reach out to a contact of ours or an employee in another company and ask them to reboot a device or recover it. So, we aren't a purely software platform, and I think it's good to keep that in mind if that's not something you think about all the time. Our cloud deployment does sometimes include AV boxes and TVs. I think pretty much just in the dedicated devices at the moment. Perhaps at some point there will be AV boxes in our shared pool as well. The other model here is on-premise. So that's when the customer is hosting some or all of the hardware. So the most common driver of this is, security reasons. Customers want control over the devices and or the apps they're testing, right? Maybe they're testing a pre-release phone. Maybe they have a very high security app and they want to make sure that no one can run in and steal a phone, and, then create a problem for them. Of course, we also have security compliance in terms of how we run our cloud infrastructure. We do provide some assurances there, but nonetheless, some customers want control over that. I'm going to spend a little bit of time just picking apart the two deployment models for on-premise. I think this may not be of interest to everybody, but it's worth going over so that we have a sense for those who do end up interacting with this. So the first model we talk about typically is called hybrid on-premise, one that has a virtual private cloud. This tends to be our slightly preferred deployment model, just in the sense that it's easier from a logistics perspective and a setup perspective for us to run. But of course, whatever the customer needs is what we provide. So in this context, the customer has the P box with the phones in it, or the AV box with the media devices in it on their premise. But HeadSpin is still going to host what I referred to as the unified controller and all of their data. So if I go back to my architecture diagram from the beginning, everything here on the left, and they could also have multiple sites if they want, or they could have a single site. They'll have all the phones and the devices, and they'll also have that first layer of computers that debugs the phones. So the P boxes, the AV boxes will all be the server blades on their site. But we'll still be hosting this cloud infrastructure where they connect to. I did note that this is a virtual private cloud, which means that these customers are separated in our cloud from the rest of our production cloud. This is both for our security and their security. So customers are still isolated from a security perspective from each other. The other model is what we call fully on-premise, where all of the hardware, all of the data is hosted by the customer. If necessary, we can even air gap the customer. I say if necessary, I think we always try and aim to have some level of connectivity with the customer so we can provide the best possible support. It can be very hard to debug and work with customers who are fully air gapped. So just back in our diagram, that means everything, including the server, including unified controller, will be hosted by the customer. We do this by either sending them a bare metal server to run that unified controller and host all their data, or some customers might provide their own virtualized servers, their own equivalent of AWS that they want to control.